Good morning. Today we will discuss a new discovery, not a new discovery now, but in 1900s and all, it was new when modern physics was emerging. This was a new discovery that helped in the development of modern physics. That is the discovery of X-rays. Why is it called X? Where do you usually use the letter X? When you are doing some mathematical problems, when will you use the letter X? An unknown quantity, right? So when you have an unknown quantity, we use the letter X to denote that until it is solved. So when this X-ray was discovered by William Conrad Roentgen in 1895, it was not known what is this radiation, what kind of rays they are. It was not known. So it was called X-ray or Roentgen ray. Now let us see what is an X-ray. If very fast moving electrons hit a metal target, then a radiation with high penetrating power is produced. This radiation is called X-rays. So what are required here? Fast moving electrons. We need fast moving electrons and they should be hit on a metal target. So if there is a piece of metal target and fast moving electrons were incident on it, then there from the metal target, a radiation with high penetrating power is produced. So have you ever taken an X-ray? Have any one of you taken X-ray before?
Yes, teacher.
Okay, you have taken X-ray, and which part of your body did you take X-ray?
I took for teeth.
For feet? Okay, you had some fracture in your feet or something like
No, for tooth, teacher.
that? Tooth, okay, tooth. So here you can see in the background some X-rays. So why do we here see only these things? What is this? What is this picture which you can see in the background?
Our bones.
Our bones, hand, right? So can you see the flesh? Not clearly, right?
Skeleton of our.
Not clearly. So what happens is the X-rays can penetrate through our flesh, our body, and only the bones will be stopping them. That's why its image is formed here. So it has very high penetrating power. And this radiation is called X-rays because at that time, the scientists were not aware like what is this, what is the nature of this rays, why is it coming out? So it's an unknown ray. That's why it was. Someone, please mute yourself. Now, or Roentgen rays. Now, there are two types of X-rays, soft X-rays and hard X-rays. So, soft X-rays are produced when on an application of small potential difference. So, we will see next how we can produce X-rays. So, we produce very fast moving electrons by applying potential difference across two terminals. Potential difference across a anode and a cathode kept in a discharge tube. During this time, there were several experiments conducted within discharge tubes. Discharge tube means low pressure maintained tubes with an anode and a cathode, which will be connected to a external electric circuit. So if you apply small potential difference between the anode and cathode, the X-ray produced are called soft X-rays. Now, if you apply high potential difference across the anode and cathode, the X-rays produced are called hard X-rays. So let us see how the X-rays are produced. So to produce X-rays, you need a discharge tube. See, this one is a discharge tube, which is used for the production of X-rays. It is called vacuum, but the pressure is very low. It is about 10 raised to minus 3 millimeter mercury pressure. So this is a unit of pressure. So the pressure is very low, 10 raised to minus 3 millimeter mercury pressure. This is the unit of pressure. Millimeter of mercury is a unit of pressure, and this is very low pressure, nearly vacuum. So here inside the tube, you have very low pressure, and one end of the tube is connected to, it's called copper anode. So it will be connected to which terminal, positive or negative? An anode is a terminal connected to positive of the battery, and this is a cathode which will be connected to the negative of a battery. So this is the anode, this is the cathode. Cathode, you have a very thin filament which can be heated by applying a high electric current. So if you apply very high electric current here, the source is very high electric current, and this is the cathode, which is a filament, which means it is connected to the negative terminal, and here you have anode, which will be connected to the positive terminal. Now what happens is, when you apply a high electricity here, this filament gets heated up. And when the filament gets highly heated up, it will produce electrons. And if the potential is very high, what happens is this electrons will get accelerated towards the anode. And you have a metal target kept here at the anode. So these electrons will go at very high kinetic energy and hit this target. When they hit the target, most of the kinetic energy of the electrons is used to produce X-rays. And some energy will be lost as heat energy, but we assume in the ideal case that that energy which is lost as heat energy is negligibly small. So a very high potential difference V is applied between the cathode and the anode in an X-ray tube at 10 raised to minus 3 millimeter mercury pressure. This accelerates the electrons to the target, and the kinetic energy of the electron is mostly used to produce X-rays, and some amount is converted to heat. Is that clear to you how X-rays are produced? Is there any doubt here? I need some response. Is it clear to you?
No, teacher. It's clear.
Okay, thank you. So let me continue. Here, the amount...
Teacher, wait, teacher.
Yes.
I have a doubt. Teacher, is the X-rays harmful for our body?
X-rays, overexposure to X-rays are harmful. Not for a short period of time. Not for a short period of time, because we are using that for medical purpose, right? So high energy X-rays are used to treat cancer and all, which means that they can, if for a longer time exposure, they can harm our cells. That is why I will tell you one example. In medical field itself, whenever there are a lady is pregnant, when they are scanning for the child, they don't use X-rays to scan, they use ultraviolet rays. Okay, ultrasound scanning, not ultraviolet, sorry, ultrasound scanning. Why X-rays are not used? Because it may harm the baby. Okay, so high long time exposure to X-rays can be harmful to our body, but not for a short time. That's why we are using it to diagnose any fractures and all in our body. So let us see more details of the production of X-rays. Here, K represents the kinetic energy of the electron. And the kinetic energy gained by the electron is equal to E times V. What is E? What is E? E is the charge of an electron. How much is the charge of an electron?
9.11 into 10 raised to minus 19.
1.6 into 10 raised to minus.
Oh, sorry. Oh, that one is proton. Sorry.
9.1 into 10 raised to minus 31 kilogram is the mass of an electron. So charge of an electron is 1.6 into 10 raised to minus 19 coulombs. So E is the charge of an electron and V is the applied potential. We will be applying some high potential, right? So V is the value of that potential. So E into V, charge into potential, will give the kinetic energy gained by the electron. And as I told, we are considering the ideal case where all the kinetic energy of the electron is converted to X-rays. So HF, what is HF? We learned in the last class, H into F. H is Planck's constant. Planck's constant into frequency will give you
Wavelength.
Planck's constant into frequency. Energy of a photon, right? Energy of a quantum. So when each electron hit the target, what happened? For each electron that hits the target, one photon or one quantum of X-ray is given out. And its energy is H into F. H is Planck's constant. F is the frequency of the X-ray coming out. So we assume that all of the energy is used to produce the X-ray. That is why F maximum frequency of the X-ray. There can be some radiations with a little lesser frequency, which means a lesser energy. Can you tell why? Because some of the energy of the electron will be lost as heat. So if all the energy is converted to X-rays, this will be the expression H times F maximum. So this is H times F maximum. Again, you know that frequency is equal to velocity by wavelength. So this is equal to HC by lambda minimum. Why I have written here lambda minimum and not maximum? Can anyone tell? Why lambda minimum? It is
because the frequency is max.
Because the frequency is maximum. Higher the frequency, lower will be the wavelength for the given radiation because its velocity remains the same. It's all electromagnetic radiation. Now we know that the X-rays are electromagnetic in nature. So the kinetic energy of the electron is represented by E times V, is the charge of the electron, V is the potential applied. And if all of them is converted to X-rays, you will get X-rays having energy. Each quanta of X-ray will have an energy HF maximum. And this is equal to HC lambda minimum. We are mentioning here the maximum frequency. There can be X-rays with a lesser frequency as well in case the electron lose some of its energy as heat. Now, the intensity of X-rays can be increased or decreased by regulating the stream of electrons in the X-ray tube. We learned that high intensity means more photons, right? So if there are more electrons hitting the target, there will be more quanta of X-rays. So if you are controlling the stream of electrons, suppose here we keep a filter for electrons, here we keep a small grid which can absorb some amount of electrons. If we keep something to narrow down the electrons, what happens? The number of electrons can be controlled. The number of electrons that reach the target can be controlled. And hence the number of quanta of X-ray beam that's coming out also will be controlled. So the intensity of X-rays can be increased or decreased by regulating the stream of electrons in the X-ray tube. Is this point clear to you? Now, how the intensity is controlled by regulating stream of electrons, because it depends upon the number of quanta and in turn upon the number of electrons hitting. Now, soft or hard X-rays can be produced by regulating the potential applied between the cathode and anode. We now know that the energy of the quanta depends upon V, the potential, right? So, if we apply very small potential, we will get soft X-ray, that is low energy X-ray. And if we are applying very high potential, we will get hard X-rays, that is high energy X-rays. So is this clear to you how X-rays are produced and how we can vary the intensity and energy, that is soft or hard X-rays? Is this clear to you?
Yes, teacher.
Okay. So now let us see some of the uses or properties of X-rays. So what are the properties of X-rays? X-rays, you know, that are electromagnetic in nature. Now you have already learned electromagnetic spectrum and you have seen X-ray is one of them. So you know that X-ray is electromagnetic. So all the properties of electromagnetic waves will be applicable to X-rays. Do you remember the X-rays belong to the high frequency side of electromagnetic spectrum or the low frequency side? If anyone remember the order of the rays in an electromagnetic spectrum, you can tell me. Do you remember? Whether X-rays
What,
belong
teacher?
to... Yeah, tell me either the order of the rays in electromagnetic spectrum or tell me whether X-ray belong to the high frequency side or the low frequency side.
It's in the infrared wave.
Infrared, after infrared, right?
It's in the infrared wave. No, after. Sorry, yeah, infrared, radio and that things are in infrared.
No. Radio waves means after or before infrared. Infrared means what? Towards the red side, longer wavelength side, less frequency side. X-rays are in the high energy side or the high frequency side. Lower wavelength, smaller wavelength and high frequency. They are strong electromagnetic waves just before gamma rays. Okay, gamma rays are the high energy side or highest frequency electromagnetic rays are gamma rays. And just below gamma rays comes X-rays. So X-ray is also a high energy, high frequency electromagnetic radiation next only to gamma rays. Okay, you have to get some clear idea about electromagnetic spectrum. Now the properties, X-rays travel in straight line. All light travels, all electromagnetic radiations travel in straight line. X-rays have high penetrating power, you know, that's why we are using it to take X-ray of our body parts. Now, X-rays are electromagnetic and so they will not be deviated by electric or magnetic field. Can you tell me what will be the charge of X-rays? Can you guess what will be the charge on X-rays? Will it be positive, negative, or neutral? X-rays are electromagnetic in nature. Will it be positive, negative, or neutral? X-rays are neutral. It is neither positive nor negative. That is why it will not be deviated by electric or magnetic field. Is that clear to you? So X-rays are electromagnetic, so it is neutral. It is neither positive nor negative, so it will not be deviated by electric or magnetic field, and their wavelength is very small, which means its frequency will be very high. So their wavelength is very small, about 10 raised to minus 10 meter. What do you call 10 raised to minus 10 meter? There is a name for this length.
Armstrong.
Yeah, Armstrong. So a few Armstrong, the wavelength of X-rays will be a few Armstrong, and that is very small, so its frequency will be very high. Now, X-rays, like any other electromagnetic rays, exhibit reflection. See, all the properties of light rays, most of them, X-rays will have, only that it is not visible to us. So X-rays exhibit reflection, like light, refraction, interference, diffraction, and polarization. So all these properties of light are shown by X-rays as well. And then X-rays affect photographic plate, just like light rays, UV rays, ultraviolet rays and all. X-rays can affect photographic plate, and they cause photoelectric effect. Have you learned what is photoelectric effect before? If you haven't learned, don't worry. Our next topic will be photoelectric effect. We will learn about photoelectric effect. And X-ray can create fluorescence on zinc sulfide and barium platinocyanide. So also X-rays can cause ionization. Wait a minute. Do you know what is meant by fluorescence?
Small particles of light.
Yeah, fluorescence means you have a peculiar color of light coming out from something, right? Now, what is actually
Yes.
happening there? What is actually happening there? Some objects can absorb some small wavelength and give it out in the form of light. So when X-rays are incident on certain particles like zinc sulfate, barium, platinocyanide, etc., there will be scintillations or small light sparks. That is called fluorescence. So X-rays can create fluorescence. That is one way to see the presence of X-ray. If you keep a zinc sulfide screen in its path, there will be scintillations or fluorescence. Then X-ray cause ionization. What is meant by ionization? What is meant by ionization? Ionization means producing ions. When X-rays pass through certain gases, what happens is they are high energy rays, right? So when they pass through certain gases, they will hit at the electrons present in atoms. So they can kick away the electron from the atoms of gas molecules. So what happens is the gas atoms will become ions. They will become positive ions because they lose one electron. So X-rays can create this. It can cause ionization. So these are the properties of X-rays, and due to these properties, X-rays have several applications in our different fields. So before going to the applications of X-rays, let me just ask you whether the properties of X-rays are clear to you. Do you have any doubt in this? Is it clear? Please respond.
Yes,
Yes,
teacher.
Teacher.
it's clear.
Okay. So now let us see the applications or uses of X-rays. You must have known in which fields X-rays are used, right? Can you remember some of the fields in which X-rays are used?
Medicine.
Yeah, medical field. So what are the uses of X-rays in medical field? X-rays are used for analysis, for diagnosis purposes, right? So then one of you, I think Hasina, told that she has taken X-ray of teeth. So dentists use them to find complications in the gum area or something like that. So cavities in teeth and impacted teeth. So we take X-rays of the teeth, and then we also take X-rays of different body parts, so that if there are any cracks or fractures in our bones, some dislocations, bulge areas of bones, etc., we can identify through X-ray images. So soft body tissues are transparent to X-rays, and bones block
Teacher,
X-rays. Yes.
can
Yes.
we detect tumor through X-ray?
Tumors, I'm not sure, because tumors are like body parts, right? Flesh. It's not bone. I'm not very sure. I think it will be either X-ray or gamma rays, which will be, no, gamma ray will pass through it. Just before X-ray, what do we have? Ultraviolet? I think ultraviolet. Ultraviolet rays or maybe soft X-rays may be used to detect tumors. I'm not very sure. I'm not, I think ultraviolet to soft, not hard X-rays, are used for detecting tumors, because tumors are again tissues like our body tissues. So not with hard X-rays, of course, maybe with soft X-rays or ultraviolet rays. Bones definitely block these even hard X-rays, so we can use X-rays for scanning purpose. Then industry. In industry, X-rays are used to inspect products made by various kinds of materials. X-ray machines are used in airports to check luggage. Have you seen the luggage checking area, what the person sitting inside that? There will be a covered place, right? We have to send our luggage through that, and there will be a person sitting inside and checking if there are any metal parts or other things which are not allowed passing through the in the luggage. So there also we use X-rays. And in science, maybe the X-rays are used to analyze the arrangement of atoms in many kinds of substances, particularly crystals. And archaeologists use X-rays to examine Asian objects covered by a crust or dirt. So to know the bone parts or some metal parts, I'm sorry, archaeologists use X-rays. So for research also, archaeologists use X-rays. And in consumer goods, X-rays are used in consumer goods that manufacturers treat certain kinds of plastic. Oh, okay. They are using it for certain kinds of plastic to check the quality of mass-produced products. So they can just scan it through X-ray and find if there are any faults or errors when they are producing certain things. And they are used in research involving quantum mechanics, theory, crystallography, examine the arrangement of atoms in solid, as we said, in science field, and also in cosmology. Cosmology means the study of organs and eventual fate of the universe. So origins and fate of the universe, I'm sorry. So how the universe originated, in that research also X-ray studies are conducted. Do you know some other uses of X-ray? You can share here. If you have knowledge of any kind of X-ray uses of X-rays, you can share it here now. You don't have?
Teacher, I saw for medical use only.
Only for me. So there are many other uses as well for X-rays. And I heard that I have one of my friends who is working with space research. So she's in ISRO, one of my college mate. So she's in ISRO now. She's studying on some of the black holes and all. So she is telling that we can identify black holes because there will be X-rays in that region. Near, if there are black holes somewhere, so at a particular distance from there, there will be X-rays. So in astronomy also, there is use of X-rays. So in many areas of science, X-rays are used. So there are applications of X-rays. So that's all I want to discuss today using X-rays. What all did we discuss? We discussed who found X-ray and when. So it was William Rogen.